Hey, everybody. Welcome to this evening's Fine Home Building webinar, LVL and PSL. What's the difference? Thanks for being here very much. So tonight's panelists, we first off have Steve Rudowsky, who's Weyerhaeuser's Truss Joist Territory Manager. He focused his efforts on serving builders using products for residential construction. Prior to his 6 years at Weyerhaeuser, Steve was a third-generation builder who worked alongside his father constructing commercial, residential, and agricultural buildings. Steve, thanks for being here.
Thank you for having me.
Brian Campbell's a finished carpenter and a fine home building contributor for Solid in St. Paul, Minnesota. He has a bachelor's degree from Colorado State University, where he studied forestry and began learning about wood science and wood properties. Brian is passionate about methods of finished carpentry that produces good, work efficiently, and is excited to begin training and developing new carpenters at Solid. And we have Ian Schwandt. The skills gained through Ian's 4-year apprenticeship opens doors to a vast array of opportunity within the building industry. Being the foreman on a production finished carpentry crew led to working as a superintendent on large commercial projects for the healthcare industry. A desire to return to his roots as a carpenter and craftsperson started a journey from flipping houses in the recession to operating a one-man architectural woodworking shop, and finally coming full circle back to residential remodeling as a lead carpenter. Recently, Ian has shifted his focus to applying his experience in managing the cost structures of commercial construction to residential remodeling as an estimator and project developer. Well, thanks guys for being here. It's really, I'm really excited about this whole subject because there's a lot of solutions or a lot of problems that can be solved with these products, and their strength and dimensional consistency is amazing to me. Steve, do you want to start us off?
Sure. So I just kind of pulled together quickly. Let me share my screen. So bear with me 1 second. Just a 4-page or a 4-slide PowerPoint. See if it works. There we go. And it goes right in. So welcome everyone. Thank you for joining us tonight. I know in the East Coast, we're already at 6 o'clock, and for the rest of you out there a little bit sooner. But I just wanted to give a little bit of background on the two products we're going to be talking about tonight. So when Fine Home Building came to me, they asked about if we could kind of have a discussion about the difference between Microlamb Lvl versus Paralamb PSL. Throughout North America, both of these products are typically available in just about every market. They may vary in some of their strength or some of the offerings that we have. Might be in size or even in its ability to come as an exterior treated use. So I think that's kind of where we're going to direct the conversation tonight. So let's just kind of jump into what we're really looking at. When we talk about engineered lumber, what we're really trying to do is engineer for the predictability of performance, that no matter how long or how wide or how thick of a piece of material that we're pulling out of what Mother Nature grew, we're always going to know what happens from 0 all the way out to 60 feet, if that's what the press is actually making. And no matter where you cut that material, it's going to have the same design values and quality that our contractors are used to seeing out on the job site. Our materials are dimensionally stable, so you're not going to have the shrinking and the swelling that you typically might have with conventional milled lumber. And because we're able to engineer it, we can engineer out the defects so that we can make it stronger than conventional lumber. The distances that EWP can carry far exceed even what multi-ply 2x12s can do in today's building environment. We actually make 2 different sizes in our EWP line, and we have it so that we match up with our EWP sizes as well as 2x construction. So let's say you're building a house with conventional framed lumber on the floors and you're using 2x12s. Typically those joists are going to be around 11¼ inches. So we make Paralamb and we make Microlamb at 11¼ When it comes to engineered lumber, our floors, we have a 9½ system, but typically you're looking at 11 7/8. So we also make it an 11 7/8 that works with that inherently. The reason that we do that is when you're working with standard construction practices and conventional lumber, mixing of materials isn't the typical way you want to go. And what I mean by that is if you're working on a conventionally framed floor, or I'm sorry, on an EW floor, like with a TJI, we never want to be able to have a rim board that matches up, or a beam or something structural that matches up on the outside that has the ability to shrink and take away from the design value of the entire system. What we're going to talk about tonight, most of the products on the PSL and the LVL side are going to be used as beams, headers, columns, and in some cases, I have projects on residential as well as commercial that are using these bigger laminations for floor joists. So we'll kind of zoom in a little bit, take a look at the Microlamb Lvl. This was one of the first products that was developed and brought into the Weyerhaeuser family when Weyerhaeuser acquired it, would have been around 2000, but there's a lot of history we could go through, but that's for another time. But let's talk about the pros and what the availability is in this product. So everything that Weyerhaeuser makes in LVL comes out as an 1 3/4 ply. We may have competitors that go with multiple sizes in widths, and that's because they don't have the ability to make Paralam. And that'll be our next slide that we talk about. But the 1 3/4 that is really good is that it's lighter for multi-ply installation. So if you need to build up a beam, whether it's a 2, 3, or 4 ply in a very tight renovation situation, you can do it in place. You don't necessarily have to take the wall out to bring a larger beam in. It works great in the renovation work where it's tricky. And the other thing is we also have the ability to make our Microlamb Lvl up to 24 inches deep. And when you say 24 inches deep, it doesn't seem like a lot until you actually see that product in front of you. And 24 inches is a massive, massive piece of wood. Some of the bigger cons around, or the things that we aren't thrilled with the Microlamb, is that when you're doing these multiply connections, it requires an engineered, detailed connection. And that's typically going to either be a nailing connection, spacing, size of nail. It could be a bolt through connection. And if we're getting into side loaded beams, or where we have beams that are loaded differently from 2 different sides, those connections become even more important. And as we started adding point loads, now we have to worry about the connection around that point. If it's in a hanger, that kind of brings up even more details. So it's great in some aspects, but it's not your end-all solution. The other thing is when you're working with multi-ply material, it's going to require frequent top edge bracing for the lateral stability. Depending on the type of houses you build and where you are in North America, we always try to keep the headers up as tight as we can so we can laterally brace them with either a ceiling joist or a floor joist. We have some customers that like to drop those headers, especially in garages, just to keep them down lower. Seems to make it easier. The problem is the amount of weight when you get into a multi-ply member, when you don't have lateral stability pulling back to hold it in place, those connections are really there just for shear to keep the material together. We have a lot of times where that weight will actually force a rollout or a buckling of the material. And the other thing is Weyerhaeuser only makes a dry use only LVL. So what happens to the rest of the world that lives on the ocean, lives on a lake, or areas that maybe they just want to have a deck outside, center of the United States, but they get a lot of rain. So we are limited, but it does have its place within the building industry. So when we talk about Paralam or PSL, this is where we talk about our builder preferred single member installation. So where I talked about with Microlamb, that only comes in 1 3/4. Paralam actually comes in multiple widths. We have a 3.5, a 5 1/4, and a 7 inch. And when you add up all of those numbers, that's going to be a 2-ply, a 3-ply, or a 4-ply LVL. But we're doing it in one solid piece of material, which kind of negates the fact of we can reduce lateral stability. We don't have to have that bracing requirement. Because of the structure of the material, we have column applications. And the greatest part about it is we can substitute Microlamb Lvl without additional design analysis. If we have a plan that comes in and it has 3-ply LVL, but we don't have enough material, or the builder can't get his hands on it, but can get Microlamb, we don't have to go back and either calculate the design values or go to the engineer of record to ask. It's an even swap. Going the opposite direction is not as easy, especially if we're looking at side-loaded and point-loaded beams when working with Microlamb. One of the other great pros is that Paralamb, because of the way that it's put together, it actually has some capillary spacing between the fibers, which makes it fantastic for wet use application, because we have a product called Paralamb Plus that can actually take treatment to be exposed in wet weather, salt splash, everything but traditional salt embedment. So you wouldn't be looking at this for like a pier application, but it would work in fresh water. Any of the cons that we might look at, product type and size are going to be market limited. So the Paralamb Plus is really only available from, I'll say, the Mississippi River to the East Coast. And on the West Coast, we actually make a Paralamb that is stronger than the East, what we call Paralamb 2.2. And that's because they have such a large wood basket of Doug fir that has higher design values. They get a little bit stronger Paralamb, but that stays towards the West Coast. Everything's going to be printed on the material, so you'll know what material you're getting. And even when it comes down to if you want to know, is there a difference between exterior and interior use? It's going to say that it has been treated, or it's going to say not for exterior use right there in big dark letters, so that there's no chance of of switching them out, because using something in an exterior wet application where it's not supposed to be is just kind of a recipe for disaster. So that's kind of my jumping off point.
I got a question already, Steve. So
okay.
the treated PSL, does it have like the same kind of retention levels that is found on conventional treated outdoor lumber? Like, are they direct swaps, I guess, is the question I'm trying to ask?
So the material that's used for the treating is a water-based material. It should be what they call a CCA treatment. So it's the same what they're using in Southern Yellow Pine 2x10s and 2x12s for decking. Southern Yellow Pine takes treatment very, very well, and that's why they use it. It's also a very strong material for a pine. It's going to take the treatment the same. If you cut the material, it's going to be treated all the way to the core. Some of the things that have come up over the recent 2-3 years, even with decking, a lot of townships and code officials are even pushing for a top lamination or a top membrane for any type of treated material, just to keep that longevity pushing forward. You have to remember, we're not treating for resistance to water, we're treating for resistance to damage that water can bring in. So we're talking about mold, fungus, things that would grow, and actually bugs that get in and eat and destroy it. But strength-wise, yes, your treated is going to be similar to conventional lumber. You will lose some reduction in design value just because you're adding treatment. Anything that you add water to, you will get a fiber bending that.
And outdoor wood products have a lower value anyway, right? Because it's decided that there's going to be special conditions that make it a more challenging environment, right?
Correct. And I think the IRC code, if it hasn't changed yet, decks required a certain loading with snow load. Now that they're going with whatever your interior load is, I think it's 1.5 times that for the exterior. So if you're at a 40 pounds per square foot live load on your interior floor, I think decks now it's 60 pounds. Obviously, if you're in more snow prone areas, they're going to have some snow loading that's going to kind of go into that as well.
Ian, Brian, what do you think about all this?
Have you had any issues over the last couple of years with availability of your raw materials, the same way that sheet goods have had?
No, we're just jumping right in, aren't we? That's fine. Yeah, anybody that is a manufacturer of engineered wood products or even wood products in general, it's been a struggle. There's been a lot of different things that have happened through the supply chain, whether you are a lumber manufacturer or you make windows or even supplying the final finishes for the house. I think the bigger reason that lumber is looked at so intently is because after the foundation goes in, we're the next ones in line. Yeah. If we were the window people, if we were somebody else, we have a little bit more time. You can kind of still wrap your house in and keep going. We're the next step after the foundation. And Weyerhaeuser here, we are doing everything we can every day to find fractions of ways to increase output to satisfy the demand. The other thing we have to look at too is we're in a building boom that we've never seen before. We've never seen it so good and so bad at the same time, I like to say. People are building more than they had prior to the, we'll call it the Great Recession. And moving forward, it's going to be a struggle. The United States manufacturing facilities and even our distribution abilities is really geared to a 1.8 billion housing starts. We're well past that. We're in the 1.8, 1.9. So it's just a struggle to keep up to it.
Brian, what problems structurally have you used these products for in your residential work?
I mean, yeah, we've used them as headers, beams, columns. The PSL we used it as columns, and we've even used it as columns under steel beams when we needed to have a.
Because then it's easy to fasten to versus a steel column, right?
Yes, and well, and we've used them exposed and just had them stained and finished. You know, so that some people actually like the look of the exposed PSL post. You know, so or beam, which is kind of interesting.
Yeah,
have you heard of that before, Steve? Folks painting the PSL and leaving it or staining it rather?
Oh yeah, absolutely. One thing I want to just start off with is it's not an architectural grade material by any means. It is softened on the edge to reduce splintering and chipping and things like that. And it does have stamps on it. It's not going to be those beautiful arches that you might see in some of the big open spaces. But yeah, we have plenty of people that have sanded them off, houses that use them for exposed beams. We have documents showing what the pH of the products need to be in order to work with the resins that go into the product, so we don't have any conflicting chemical reactions.
I think it's really cool looking. So we got a question from Armando, who asks, if I use truss joist details for TGIs, beams, rim joists, etc., do I still need to get an engineer's stamp?
So if you look through any of the literature, and this is going to really be across the engineered wood products board, this isn't just Weyerhaeuser. So if you were to pick up our TJ 4000, which is all about our floor joists, our I joists, or TJ 9000, which is about the beams we're discussing today, though you could build an entire house top to bottom, and if you follow the exact layouts and mathematical calculations, you will have a perfectly sound engineered home. It's when we get outside of those parameters that it gets a little fuzzy. Everybody wants bigger, longer, smaller. Can we use less material to go twice as far? That's when it doesn't necessarily mean you have to get an engineer involved. We always like that because it just gives more credibility to what we're doing with the product. But there are software solutions from Weyerhaeuser out there, one of them called Forte Web, which is free for anyone to sign up for. And you can actually do the calculations of what you're trying to build to see, could I use a smaller beam in this location? Or what happens if I want to use LSL timber strand as a roof joist? So there is ability. It's probably a 50-50 split in the Northeast. If we get a house, sometimes we'll have 50% of the time there's an engineer stamp with it. 50% of the time it's just an architectural drawing and it says by manufacturer. So at that point, Weyerhaeuser or a dealer distributor that is running Weyerhaeuser software takes it upon themselves to do a layout and run the design on it.
So Patrick, when I designed and built my house last year, I used Forte to come up with what I needed for some of my beam sizing. And then also because my eave height for my walls was outside of Wisconsin's model code, I switched to LSLs. Otherwise, my inspector was going to have me have to have it engineered and stamped. But by switching to LSLs at that time, which were still marginally more expensive than regular lumber, the prices hadn't quite caught up with each other yet. I was able to do the taller 11-foot walls without jumping to engineer stamping.
Obviously, your builder or your building inspector was satisfied with the design software, Ian?
Yeah, and when he came and did the framing inspection, you know, he just laughed and said, "You built the whole house out of engineered lumber. I don't have anything to look at."
Did you find the software easy to use? Was there a learning curve associated with it?
There was a learning curve for me. I think I had to kind of get some wrong answers a few times and have it reject what I was trying to do before I understood it. But also the published charts that you can find on the website were also really helpful as far as understanding what I was putting into Forte.
Steve, is that common enough that folks in the field can figure this stuff out without needing, you know, a specialist at the lumber yard or an engineer or an architect?
Yeah, I mean, if you are a builder like Ian and Brian, it makes sense to run it because you have the ability. You're sitting there going, I need to do this now and I can't wait. But if you are a homeowner that just needs to run one beam, not that it's a huge learning curve, but you probably just want to work through your lumber distributor to get that taken care of, so that when it comes into either the tech support at Weyerhaeuser or if a territory manager gets it to calculate the beam, we can have conversations to make sure that we're collecting the right information. The learning curve is very easy. We actually do a 4-day webinar, 1 hour each day, to show people how to use Forte from signing up all the way through commercial loading if you were to have a bank safe somewhere sitting on the floor.
In a previous life, I worked at a lumber yard for a spell, and there were two different softwares, as I remember. One for calculating beams and relatively simple stuff, and then other software for designing floor systems. Have those been combined, or is it still two different software programs?
So now they've been combined. Forte Web can do all of that, but it's a single member sizing type software, but has the ability to stack loads. So you don't have to keep inputting the same information. If we have a floor joist that we ran and it passes, and now we want to know about connecting it to a beam, let's say we want to do it as a flush beam, we can link the load from those joists, and the computer's smart enough now to talk to the beam to the point that it'll even work with Simpson strong tie hangers and give you the hanger that you would need to make that connection.
Cool.
And I actually used that function of it in designing my house because I have a fully exposed basement and 2 stacked patio doors. The one on the main floor is a 12-foot wide opening with a 6-foot wide opening below it. So I was able to use the program to make sure I was sizing those headers correctly.
And Ian, like just for some context for the rest of us, what kind of a beam do you need over a 12-foot opening? And what did you select? Was it LVL or PSL or something else?
In my case, it ended up being a double 11-7 LVL, which was really easy for me to use in the 2x6 LSL wall.
Because it's sized to just fit in there with, relative ease.
Yeah.
And the other great thing, you probably even saw, Ian, on the Forte web, in the very beginning when you open up, you can check off how you want the multi-member connection to design. So if you were doing these as top-loaded beams, most likely it was a nail connection from both sides, most likely 2 rows, 12 inches on center. Once we get into a side-loaded, it'll actually change that. And if nails aren't enough, because you have to connect multiple plies. So if you have a 3-ply, you have to connect all the way through. With nails is easy because you can pretty much get that from either side. Once you get even deeper than that, if you get up to a 4-ply, we suggest going with a type of like SWD bolt or screw from Simpson, and it will call that out. It'll even call out if you have a point load, what the pattern around that hanger or that point load needs to be in order to transfer that to its reaction points.
That is so cool. And it seems so useful with the, big houses that we build now with large spans, have these things grown in popularity, Steve, in your observation?
Yeah, I wouldn't know the numbers, but I know that we're a couple hundred people a day have been signing up for Forte Web, and don't hold me to that number, but I know we have, I want to say we've surpassed over 10,000 individual users now that it's gone to the web base. I think it was about 3 years ago we got removed from regular desktop. And for those of you, I know it was a tricky situation, but now we have the ability to roll out solutions and tell you about them instantly. The idea behind any web-based software is to fix problems or to introduce new opportunities without the user having to worry about updating.
Brian, what do you want to ask about these these beams?
I was wondering, it seems like you need bigger trees to peel the veneers to make an LVL, and that you can use, smaller, maybe faster grown kind of plantation trees to make the PSL fibers.
Yes. So the way I explain it, when you're making LVL, there's different grades of veneer that come out. We usually look at them as like A, B, and C. And the mix of those veneers is what gives the strength and everything to that beam. When you have, let's say, a log that's peeled and the veneers are kind of sporadic, I look at PSL as almost like a positive byproduct of LVL. We can then shred down and make smaller strands out of what wasn't usable and put it into another technology. At the end of the day, Weyerhaeuser, we are a forestry company. We grow for tens of generations ahead of us. And what we need to do is how to figure out how to get the most from each individual piece of fiber so that there is nothing wasted going into a build. The more fiber that we can use and the less of it that we can use in each individual piece to keep the same strength and quality, the more there'll be for future generations to continue to build with.
So now the same size equivalent PSL is a stronger product that can span farther than an LVL.
Correct, in some instances.
Yeah, and it has higher design values for the most part, and it's more expensive, but it seems like it's made out of less expensive components in that you're able to use, you don't need the more expensive veneers that go into an LVL. So is that a higher profit margin product for your company?
I think it's just another, I wouldn't say it's a higher profit margin, and that's not where we're running out with that. Other than a way to come up with more ways to use wood. Weyerhaeuser comes up and we look at things at like a good, better, best. One of the products that we are not talking about tonight is our TimberStrand LSL, which is another beam stud header material that's also
if you don't mind, Steve, just briefly, since we brought it up, and I'm sure folks are curious, what is that in comparison to LVL and PSL?
So we have a plant in Kenora, Canada, Ontario, where we make a product called LSL TimberStrand, and it stands for LSL is laminated strand lumber. And what it is, when you look at the product, it almost looks like a very dense and larger version of an OSB subfloor. And the way that it's put together with its material, the modules of elasticity are lower than the beams that we're currently talking about, but its capability to resist shear is much higher. So to put that kind of in just standard builder terms, we may only be able to go 12 feet with a LSL for a beam, but I can drill a hole 6 or 8 inches in diameter into that beam and put a point load on top of it or next to it, because it can resist shear that much better than the other two products. Now, that being said, we're trading distance for strength in that application. If it comes to, we don't need to put these big holes in, we're not getting ducts through there, we just need to get smaller water lines, maybe a couple of power cables, a PSL and an LVL are always going to be the way to go. But to get back to Brian's question about, it seems that it's easier to make, or we can use less expensive veneers. That is true to a degree, but we're also saving the time for the builder. Ian, if you had to screw those together with Simpson screws, what is the value if you were hiring a guy to put those screws in, making sure he gets them right, and making sure that the connection works? So you give one for the other. Sometimes, and it also depends on the market that you're in as to what is in demand, as to what the price is going to be.
What are the respective species we're talking about for the LSL product, Steve?
So the LSL out of Canada, that is aspen.
Really?
And there might be,
I bet they blend, right? With aspen, with pine and spruce, and, or is it
there might be some blending. I don't remember right off the top of my head, because that's the other ones. I mean, I know what we're putting together in a Microlamb and what's going into a Microlamb and all of that. From what I remember, I want to say that outside of resin, which the LSL has our highest amount of resin, which actually comes in less than 5%, the rest of it is all virgin wood. When we talk about engineered lumber, none of this is recycled. We're not tearing pallets down. We're not introducing anything. We don't know what chemicals are in those pallets. We don't know what they've been used for. And a lot of recycling of lumber into other things. Now you also are introducing water to either clean it or change the fiber into something else. We lose the design properties. So anything that's coming out in an engineered lumber capability right now is plantation grown product.
We got a couple questions from our attendees. Francisco asked, do you anticipate replacing many applications that presently use Doug fir, or can it replace many Doug fir applications? I guess, Francisco, and you can reply back if I get this wrong, but I think he's asking if these are a one-on-one substitution to use the Doug fir PSL or PSL instead of large Doug fir timbers, I'm guessing.
So it's going to depend on the application. When it comes to, like, say, a type 3 multifamily house where you have a burn rating for an exterior wall, engineered lumber is not accepted for those structural applications, where larger timber Doug fir is the approved version for a header or a beam that is supporting that exterior flame wall. As a direct substitution, I mean, in order to get the same span out of a timber frame, we'll call it, it's going to have to be larger than what a Microlamb is. There's going to be defects. There's going to be things within that that are going to limit its ability to perform the same way. Not just that, depending on what tree you're getting it out of, you don't know the predictability of, is it going to twist? Is it going to crown? If that's right in the center of the floor in a grand dining room and with marble tile on it, and it decides it's going to buckle, I don't want to be the one that's got to replace the stress cracks in that marble.
That makes me anxious just hearing you talk about that.
To that point, Steve, are you finding that your target market is the single family home builder and designer, or more so some of the larger multifamily 4-story structures that are now being built out of out of lumber?
So we're really selling on all markets. Yes, the residential side is a huge place for us to put that material. Even in, let's talk about multi-story housing that is using open web trusses. A lot of times Weyerhaeuser is in that market working with those open truss manufacturers because of what our beams can carry, what our rim boards can carry, that we can help. We don't have to be the entire building. Yes, we love to be, but we can help be part of the building to make it better. So we're working on all of those. Even in mass timber construction right now, I know we've supplied some of the beams for projects in, I want to say Western Canada. I don't remember the ones off the top of my head, but posts, columns, things like that. We have the ability to make those for just about any type of application that they can support. I mean, our 7x7 Microlamb columns can support a 40,000 pound load. You look at built up 2x4s, 2x6s, I think we top out at less than 10,000. And that's a huge difference when you start stacking these multi-story homes or apartment buildings. By the time you get back down to the ground level, there's a lot of weight coming down in those areas.
Armando asks, is there an average or minimum age when the trees are harvested to make these products? I'm guessing it varies depending on what you're making, but I don't know that.
Yeah, so it's going to vary. And as technology increases on how material can grow, those harvest limits are going to come back. But I would say on average, a Weyerhaeuser forest cutting is between 22 and 25 years after planting. And I know we have a couple southern mills in the Carolinas that make other products that I think we've gotten what we call framer series. We've been able to get that down to, I think, 18 to 20 years. So depending on the genetics of what we're growing, the seasons that we're getting. I mean, as Mother Nature keeps throwing different things at us, whether it's hurricanes, tornadoes, floods, fires, you name it, it's an ever-changing landscape of when we can harvest, what we can harvest, and sometimes is there anything left to harvest?
Michael asks, how long do these materials outgas for? Is there a metric for the amount of outgassing? Do they meet TASCA certifications? Where can he find this information, he asks?
So because I'm not a chemical engineer, I really don't want to get too down in the weeds on that, but I will provide a link to that after we're done talking. We get into the questions and answers. We do have a tech bulletin that describes any type of environmental hazards from the product. We meet all of the air quality requirements that are typically found in California. We base ourselves as a sustainable and healthy product based on the most stringent home building codes that are out there.
Did you have a question, Brian? I thought I interrupted you earlier.
Oh, well, I just had one thought that the labor saving on not having to create your own laminated, 2-ply or 3-ply LVL beam by switching to the PSL product. That's much more achievable if you use material lifts to, place beams, or if you have a, forklift or a boom or a crane or
correct. Absolutely.
Yeah. The better you're set up for lifting, the more you can take advantage of the labor saving which that introduces like two different layers of labor saving. You know, just the lifts save labor and effort, and the product not having to laminate it, that can save a lot of labor.
And it would be in many cases smaller in cross section than something built up, right?
No, they're going to come out to the same. So a 2-ply LVL, 1 3/4 and 1 3/4 is going to be 3.5, and that's where our Paralam starts, is at 3.5. So they'll all ply out to the same.
Is there a reason, Steve, that the Paralam doesn't come in a narrower width? Why is that? Is it the manufacturing process or no demand?
So we actually about 2 years ago tried to do a smaller Paralam, a narrower one called 2.69, because we took a look at the entire area that we were building in and said, all right, so for typical header applications on windows and doors, do we really need a 3.5 inch? A lot of times we need more than 1 3/4, but we don't need 3.5. It really didn't get the fanfare and the takeoff that we wanted. We really can't go any smaller than that. And the reason for that is we can't control how the material reacts to the weather. If it gets wet, the smaller the cross section becomes, especially in Paralam, the better chance we have of warping. Now, if we were to make, say, 1 3/4, make it, press it, wrap it tight, ship it to a job, it went in and it never rained, I'm going to say, yeah, it's 100% possible. But the building cycles, as we know, don't work that way ever. Nothing's ever on time.
Yeah. House frames get wet. That's just a reality of building anywhere but the desert.
Right.
What lengths do those products ship to lumber yards in? I mean, a lot of those you pay by the foot, and they're cut to length for your order. And I mean, they come semi-length or rail car length, or I mean.
So it depends on what you can receive. We have some customers that'll take rail cars. Rail cars, I think we can ship up to 60 feet. So that's where our presses max out at. Overland trucking, standard United States without having to go for extra length is 52 feet. So a yard, so taking 52 feet, a 52-foot material is very possible. The limiting factor in that is the size of the yard and the size of the equipment they have to move that. You need a much larger spread on your forks in order to support a 52-foot long bundle of material.
The biggest we would handle was 40 foot, and that was only under severe pressure from a good customer, because it does get pretty wonky on the forklifts and on the trucks. You know, even at 40 feet, you have a big honking lumber truck and it's still overhanging the racks, you know?
Right. And a lot of lumber distributors will also bring in lengths that they know they sell on a regular basis. So they'll go throughout their history and say, we do great with 24 footers because we also can get 12 footers out of it and we don't have waste. So they may be cutting down that material in the yard for you as the builder, but they're also looking at, by the time they get done cutting all the way through a 52 footer, if they're left with a 6-foot piece, nobody's coming in usually just to buy a 6-foot piece. Every once in a while, a lot of times that's a cutoff from something else that they'll use in a stair header or ply up into a smaller beam. So it regionally, it's really going to depend on what the lumber yards are bringing in.
I'm going to remind our attendees out there, if you have any questions, please put them in the chat. We'd love to answer them with our experts. And I wanted to know, are there regional preferences for certain products that owing to the building methods or the size of the houses or styles of the house that you can pick up on?
Absolutely. Like I said, New England and the mid-Atlantic states down through, I'd say, Virginia are very big into Paralam. One, it comes right out of our Buchanan, West Virginia mill. So it's a very easy source for us, but we also source our same Microlamb from there. It just, in our markets, our builders really have taken on to the idea of Paralam, and especially the Paralam Plus or the treated, being on a shore coast of, you have the Virginia beaches, you have New Jersey, New York, Long Island. the fact that we can provide in a salt environment and wet environments also is a huge benefit.
Well, on that subject, Joseph just wrote to us, can LVL and PSL be used outdoors, exposed to the elements, or do both products have to be covered and protected from the elements? Thank you. You touched on that a little bit, but I think if you could go through that again, it'd be helpful.
Right. So Weyerhaeuser's LVL is an indoor dry use only. So when we consider something dry use, we have to be under 16%, like right around that 16% of relative humidity or water in the air. So your typical basement exposure is fine. And that's going to fluctuate through the year. So we're going on an average over the year. Obviously, your summers in the Northeast are going to be a lot wetter than what you have during the winter months. We do not make an exterior grade LVL. We do make two different types of LVL, though. We make one called a six-sided sealer, and we also make one called WSO, which is watershed overlay. And most of our WSO, it's an orange color. It has like these tiger stripes on it. The only thing that is there for is protecting the material during the construction phase from moisture uptake. And really it's to help with any type of buckling or swelling. As you get larger or you start to increase the depth of your material in such a narrow cross section, you have a tendency to buckle if you can't keep that moisture out. So we do make two different kinds just for that application. When it comes to Paralam, we make a interior version and we make an exterior wet grade version. Our Paralam Plus or PSL Plus is going to be a very dark or almost military green type color. It's going to be stamped that says treated, and it's going to be stamped on its narrow face. Our regular Paralam is going to be stamped on the wide face, and we're going to we keep them separate in the yard as well, just so that there isn't a confusion as to what's coming out. But for exterior use, that Paralam Plus comes in beams as well as columns. So, and if you can direct bury the columns. You can't do a direct burial for saltwater application, but if you're direct burying posts for an exterior deck, they can go right down on a 3-foot deep footing and you can pack soil right around them.
So are the treated products available in all the same sizes as the regular Paralam, or is it a smaller
No, we are
offering?
limited. We do 3.5 by 3.5 inch columns all the way up to a 7 by 7 column. So we would have a 3.5, 3.5, 3.5, 5 1/4, 5 1/4, 5 1/4, and 7 by 7 square. So that's going to fit underneath to the exact sizes of our Paralam Plus beam. We make treated beams, or the Paralam Plus beam, in 3.5 wide, 5 1/4 wide, and 7 inch wide, but we only go up to 16 inches deep. Paralam can come from the West Coast as 24 inches deep, and regular Paralam on the East Coast is only manufactured to 18 inches because of press availability or capacity. But at the end of the day, the ability to get the treatment all the way to the core of the material is the high priority. So a 5 1/4 by 16 is going to be the max that we're going to make.
Brian, do you have any questions before we go here?
I have an observation. Because of the length of the material that a lot of lumberyards stock in these products, a lot of them end up out in the yard, outdoors. They're not under a roof
because they're too big to be in a warehouse. Yeah,
they're too big to be stored indoors, or it's hard to get them in and out of the building, or for whatever reason, you'll see yards with those stored outdoors, and they're not. I would say that some yards are not great at making sure they're always well tarped, so you can sometimes see some of those products show up where they've gotten exposed to more water before you got your hands on them as a builder than you would like. And so some of the laminate, they aren't perfectly flat. Some of them have cupped. And by the time you build up a laminated LVL beam, sometimes it's wider than the rest of the wall, or wider than Do you get complaints from end users that that some of the yards aren't protecting your product well enough?
Over the past 2 years, no, because we can't keep it in stock for it to get wet.
Right.
But yes, I mean, it does happen. And Weyerhaeuser, we have a system called what we call clean and bright. And that's what we want to sell to. When it leaves our factory, that material is clean and bright, and it is wrapped in a weather barrier material that can be used throughout. You've probably seen the white and green wrappers come. They're fantastic. Every year as we get in closer to the winter, we'll give seminars. I'll walk with my dealers through the yard, and we'll talk about clean and bright practices, things that I'll see in the yard, because the last thing I want is my builder saying, it's not a great piece of material. Look how it came to me. So I take the extra effort to work with the dealers because I want every stick that goes in there to be sold. I don't want those returns.
Yeah, Brian, you bring up a good point about professionals like us needing to know our suppliers really well and their work practices and how they relate to the quality of material we get in the field.
It does vary. I think you all would agree. Sherry asked, we're planning on building an exterior access stair using Microlamb Plus PSL beams and columns. We would like to sand and paint. Any lessons learned or preferred paints? Can you paint it?
So yeah, it can be stained, it can be painted. Again, that's going to go back to similar to the interior use. I can provide a document I'll have for Fine Home Building to put up on their website that will speak directly to topical coatings and what should be used. If for those of you out there that are saying, well, I don't want to do a paint or a coating, I want to wrap it in, let's say, some type of PVC trim or cedar, we also have details for that. It doesn't matter how water resistant or how treated any type of beam is, if they're meant to get wet and they're meant to dry out, or they're meant to continually stay wet, similar to the way like pylons work when you're doing a dock type application. Something that stays wet doesn't grow, and something that stays dry doesn't grow any other types of bacteria. It's usually right at the water line where you see issues. So that being said, if you're going to wrap an exterior grade beam, whether it be, like I said, PVC, aluminum, any other type of wood, we don't want to create a bucket. We don't want to trap any water that's going to get in there. And believe me, it's going to get in there. No matter what you do today, it might be great, but unless you recaulk, kind of even 2 years down the road, water is going to find a way in. That's just what it does. And if it's able to hold in there is where we're going to see issues with any type of treated beam. Not necessarily see a failure, but you're going to start to see that the service life of that beam is going to be less than what it's meant to be.
This is a good question here. Are there any chemical reactive issues with adjacent materials, i.e. aluminum, either flashing or stair treads? Because normal CCA, you can't really put, the modern formulas anyway, you can't put with aluminum, especially in the presence of water, right?
Yeah, so you are going to have reaction because they are using copper, saying copper and aluminum don't mix. So in the details in TJ 9000 for the beams, they do have a cladding detail to show how to do an aluminum wrap. And basically all you're doing is you're making a standoff, doing vertical nailers, thin vertical nailers on the beam to then wrap it with aluminum. So if that's the case, you're going to want to kind of think through the size of the beam and the size of the columns below so that you don't end up with a beam that looks like it's 3 inches too big for the column that it's sitting on.
Jim asked if you can remove or move the stamps on the beams if you plan to keep them exposed. But you said a little bit ago that people do sand them off after they've been inspected or whatever, right?
Yeah, I've never seen an exterior beam where they've sanded it off. That's not to say they haven't done it.
Yeah.
I would, if somebody came to me and asked that question, I would refer that to our engineering department as the best way to take care of that. Because the last thing we want is somebody to paint a beam, tell us that it was Microlamb Plus, sand all of the information off of it. I mean, yes, after we take it down, we can do chemical testing on it. We'll know if it is or is not. But the last thing we want is a interior grade beam stuck outside. That's not going to work. You cannot treat an interior beam for exterior use. It has to be done by a manufacturer. It's not like you can put Thompson's water seal on it. So let's also, before that question comes up, as a homeowner, as a builder, you are not able to seal this material. It has to be done through a commercial grade or industrial pressure sealer.
Jim also asked, what types of finishes or paints play well with these materials? Is there a general rule?
It all comes down to the pH. So I don't really get involved with that. When anybody asks, we'll send the documentation and you can take that to your paint store and then you can work with that manufacturer.
Rob is asking, so if you're supporting a porch roof and assuming it's not like directly at the end of the rafters, would that be considered an outdoor application or an indoor application?
So if you have an overhang, let's say it's just a standard porch roof, where the discrepancy comes in are the ends of the porch roof closed. So as long as the beam is protected from the weather on all sides, I would consider that an interior use. If you had, let's say you had a standard A-frame covered deck or covered patio that you were going to do, and you had a cross member that was going between the beams to support the ridge, but you were going to put bug screening in front of that. That beam is now exposed to weather at the posts and the cross section, so that would be considered exterior. So really, as long as the gables are covered and you have an overhang, we usually like to see 1 foot or better. So that overhang is going to be at the bottom. The bottom of the overhang will be flush with the bottom of the beam. So when your soffit comes through, we would consider that a protected beam.
But it'd be good.
You have a question? Go ahead, Brian, sorry.
Oh, so you could use LVLs for your beam, but posts, it would be better if they were a treated PSL.
Yes. I mean, obviously there's fiberglass wraps that can go, that are sleeves that go on first, standoffs on the bottom. But typically we want to see something treated, or even at that case, I mean, cedar has always been a good one to go to, a redwood, something that can resist the insects at that point.
You got any final questions or thoughts, Ian?
No, I thought your comment about the overhangs on a porch was interesting, because I did go back and forth with that on my deck at my house as to whether or not I should be using a treated material for the beam, and my lumber supplier and I did settle on what you just described with treated 6x6s for the posts and then standard lumber for the headers. Do you find that to be an application that works across the country, or are there maybe areas, you were talking about the coastal areas specifically, that you would still want to see that beam be treated?
Yeah, at least on the East Coast, because everybody wants that interior exterior kind of open concept living. 99% of the beams that go into those porches are going to be treated with stainless steel connections, things that aren't going to corrode. And it's just for the longevity. 50, 60 years ago, probably everybody that would have been on this call went out every year and cleaned their own chimney, checked their gutters. Now houses are lived in for minimal amount of time, and people just want to enjoy life. They don't want to know how to fix their house or repair things, and some do. But we need to build to make sure that people don't have to worry about it. We're building homes that people are living in, not necessarily living to take care of.
One additional question I have for you, Steve, on the treated beams. Anybody who buys other stuff from Weyerhaeuser has access to those, or is there a dealer network for that specific product?
Yeah, so that's one of the products we probably have the shoelaces tied tightest around, because it is such a high demand product. that is only, as far as I know, there's probably somebody tomorrow from my company that's gonna be like, oh yeah, by the way, but I'm gonna say 99.9% of that material is going through a dealer network.
But any dealer who can get the rest of your products will have access to that as well?
Yeah, so as long as they're a committed Trust Joist dealer within the distribution range of that product, they can get it. It's just going, if it's a, let's say somebody that currently isn't carrying it, it might be quite expensive to have one beam brought in. So you kind of have to weigh the situation as to, is it something that's stocked or is it something that's close enough to a stocking distribution center to bring in that one beam?
We got one more question, and it's a good one. Carl wants to know, why are the post PSLs 1.8, what is it, modus of elasticity, right, as is the measurement, right?
Correct.
Rated at 1.8, and the beam PSLs are rated at 2.0. Are they different materials?
No, so they're the same material. It's just going to be the way the veneers are added into it. So when you think about the direction that a column is stacking, think of holding a bunch of straws and pushing down on top of those straws. When they're compacted together with, we'll call it a rubber band, they're not going to fall apart. That's the strongest orientation, is the way that those fibers are placed. Whereas at a beam, they're running all horizontal. So you're working with forces that are trying to pull them apart as you add loads to them. So there's no reason to create a 2.0 beam because you're working on vertical loading. That beam is going to crush out way before it's going to bend. It's going to bend. I mean, yes, but and there's ratios into that. The taller you go, the less weight it can support. If it's in a shear wall and you have the ability to control that bending as opposed to a freestanding column, there's a lot that goes into that. But yeah, there's no reason to create a 2.0E column at this point because it's a waste of material, really.
Yeah, and your columns are square and your beams have depth to them. They're
right.
They're a rectangle instead of a square, so they can. And because of that deeper profile, they can handle more of a load before they deflect than a square. That's why we don't use square floor joists.
Exactly. It all has to, then that gets into the whole engineering side of MOE and MOI and the shapes of things and why an I-joist works and how it works. And I mean, we could do this every week if you really wanted to and talk about a different product. I'm up for it.
Can we?
Oh boy.
Unfortunately, that is all the time we have for this one, but I would talk to you anytime, Steve. I find this stuff fascinating, and I know that folks who are attending this webinar do too. It is really a cool subject, and the products do amazing things that, you know, I don't know that we could do with dimensional lumber anymore. Thank you, Weyerhaeuser, and thanks for all of you for being here. Thanks to Ian and Brian, and I hope to see you guys the next time. Happy building.
Thank you. Enjoy your evening, everyone.
Thank you.
Yeah,
bye, everybody.